Dear students, in the previous video we considered these examples, and by these examples we have shown that internal forces within a system of particles do not affect the center of mass. Let us see once again. Here a cracker is lighted and thrown away. It was not exploded, and it is moving under the action of gravitational force. See, it described a parabolic trajectory. It's a center of mass. Second time it was lighted and thrown, and it exploded when it came here. Now from that cracker, when it exploded, fragments spread into all directions like this. Now if you observe the center of mass of the fragments follow the same path like here. The reason is the external force here and here is same. Here the external force is gravitational force, and that gravitational force here and here same. Therefore, whether it exploded and did not explode or exploded, center of mass followed the same parabolic trajectory. It means center of mass obeys external force. It doesn't obey internal forces. Here the reason for explosion is internal forces, and the internal forces did not disturb the path followed by the center of mass. Here we considered another example. Radium nucleus is moving in a horizontal straight line. Suddenly when it came here, it disintegrated into two. One is alpha particle, another is radon nucleus. These are moving in different directions, but center of mass of the two particles is same. It will be moving in the same horizontal straight line. Here the reason for decay is internal forces, and those internal forces did not affect the motion of center of mass before decay, after decay. Center of mass is following the same path, and on this system again external force is gravitational force, but these have very small masses, so on this the gravitational force is negligible. Of course, whether it is considerable or negligible, before disintegration and after disintegration gravitational force is common. Therefore it followed the same path. Center of mass obeys external force only, and the external force is same here and here. Therefore it followed the same path, and it is not disturbed by the explosion. It is not disturbed by the internal forces which caused decay. Now considering another example, here moon is moving around earth, and earth moon system is moving around sun. The forces of attraction between earth and moon are internal forces, and gravitational force of sun on this system is external force. See here, the internal forces do not affect the center of mass of Earth and Moon. It obeys external force by Sun, and it describes elliptical path. Now let us consider linear momentum of a system of particles. Position of center of mass is given by Mn, or sum of masses of all particles, capital M, taking M left side, differentiating with respect to time, here total mass of particles of a system of particles is constant, that's why it is kept outside. Rate of change of displacement gives velocity, and this is position of center of mass, therefore this will be velocity of center of mass. This will be the velocity of particle 1, velocity of particle 2, so on. But mass into velocity is momentum. M into V is equal to P. So substituting here, P1 plus P2 plus so on. So if this is equation 1, this is equation 2, but P, that is linear momentum of system of particles, is sum of moments of the individual particles. Therefore, from these two equations you can write this is equal to this. So linear momentum of a system of particles is product of total mass and velocity of center of mass. Now let us consider law of conservation of linear momentum of a system of particles. See, here we have momentum of a system of particles is nothing but product of total mass and velocity of center of mass. Differentiating with respect to time, dv dt, or dv dt is equal to m. Rate of change of velocity is nothing but acceleration of center of mass. center of mass. But by Newton's second law, ma is equal to external force acting on the system. Therefore, dp by dt is equal to, in place of this you can write F external. If F external is equal to 0, then dp by dt is equal to 0, or dp is equal to 0 into dt is equal to 0, or here but here change in momentum is 0. It means there is no change in momentum. It means momentum is constant. So this is law of conservation of linear momentum. When external force on system of particles is 0, then P is equal to constant. P is equal to mv. Or V is equal to constant by m. Both are constants, therefore this also constant. So when external force is 0 on a system of particles, when external force is 0 on a system of particles, then P is equal to constant, or V is equal to constant. It means center of mass moves with constant velocity. Now let us consider vector product of two vectors. How it is defined? Vector product of two vectors A and B. A is A cross B is equal to C. So in this way defined, where C means what? See, if you take vector product of two vectors, you get again a vector, and a vector has magnitude and direction. Its magnitude is represented by C, and the magnitude is AB sin theta. Now we have to speak about its direction. Direction of C is given by right hand rule, or right-handed screw rule. Now let us take a diagram. Suppose this is A vector, suppose this is B vector, and angle between the two vectors is theta. Now the vector product of A and B is another vector C, and its magnitude is AB sin theta. See, now let us complete parallelogram. For the parallelogram, A and B vectors are adjacent sides. Now let us find its area. Base into height. This is the formula. Base is A. Height. This is height. See, if this is B, this will be B cos theta, and this will be B sin theta. So base is A and height is B sin theta. That is equal to AB sin theta. So vector product, the magnitude of vector product of two vectors is nothing but area of parallelogram. Now direction. Direction of C is given by right hand rule or right-handed screw rule. Let us apply right-handed screw rule. This is right-handed screw. Here A vector is there, here B vector is there. This is head of screw. If the screw is moved from A to B, the tip of the screw will move upward. So A cross B or direction of C will be in this direction. Another right hand rule is there. This is A vector, this is B vector. Your fingers are curled from A to B. Then thumb represents C vector, that is A cross B. So here this direction C. Suppose this is A vector and this is B vector. Say angle theta. So this consists of a plane. This is a plane formed by these two adjacent vectors. To this plane, C vector is at 90 degrees. C vector is at 90 degrees. But normal to this plane, you can draw a vector either this side or this side. This side vector also becomes normal to this. But which one is correct? That is decided by right hand rule. Right hand rule means, see, like this, like this. From A to B, fingers curling, thumb represents C. Or we can do one thing. Suppose you have taken a screw, from A to B. That is, you are moving the screw anti-clockwise. Then it will move up. That's why C vector will be in the upward direction. So magnitude is, so the area, this area gives the magnitude, and this direction, this is the direction. That's all. C is equal to A cross B. Now let us consider properties of vector product. First property is, vector product is not commutative. It means A cross B is not equal to B cross A. We can show this by a diagram. Suppose this is A vector, this is B vector, angle theta. Now A cross B, screw is moved anti-clockwise, means the screw will move up. So perpendicular to this plane, the cross product of these two will be in this direction. In this direction. Now, suppose this is A vector, this is B vector, angle is theta. Now, if you move screw from B to A, the screw will come down. The screw will come down. So this is the plane formed by the two vectors. This will be perpendicular to the plane and in this direction. See, magnitude is same. This is AB sin theta, this also AB sin theta, but direction different. A cross B and B cross A are oppositely directed. Therefore, you can write A cross B is equal to minus of B cross A. Okay, this is first property. Now, let us consider another property. distributive. Vector product is distributive. It means A cross B plus next A cross C. This is distributive property. Now third one. The third one is A cross B doesn't change. A cross B doesn't change sign under reflection. This is another property. See, all of you know, when we look into the mirror, see, right side becomes left side and left side becomes right side. So if you take a reference frame, x, y, z axis, x, y, z, here a particle x, y, z coordinates. See, if you see this in the mirror, the coordinates will be minus x, minus y, minus z. So these are called mirror coordinates. So here, let us take reflection coordinates. A bar in the mirror will be seen as minus A bar. B bar will be seen as minus B bar. Minus into minus plus. See, A cross B doesn't change sign under reflection. Fourth one. Vector product to parallel vectors is a null vector. See, for example, A cross A. Same vectors, so they will be parallel to each other. Now, its magnitude A cross B is equal to AB sin theta. A cross B is equal to AB sin theta. Here its magnitude is A, its magnitude is A sin angle between these two. Both are one and the same. Therefore, the angle will be 0 degrees between them. Sin 0, 0, 0 and something 0. So you got a null vector. Now, vector product of two perpendicular vectors. Suppose A cross B, its magnitude AB sin theta. if theta is equal to 90 degrees, sine 90 is equal to 1. This is the maximum value. Therefore A cross B also maximum. So when two vectors are at perpendicular to each other, then their cross product gives maximum magnitude. Now let us consider unit vectors. Unit vector along x-axis is denoted by I. Unit vector along y-axis is denoted by j. Unit vector along z-axis is denoted by k. Now let us take first parallel vectors. For example, I cross I. This is unit vector, therefore its magnitude is 1. Its magnitude 1 sine 0 degrees is 0, a null vector. So whether I cross I or j cross j or k cross k, these are parallel vectors. For parallel vectors, vector product gives null vector. Now let us consider two unit vectors perpendicular to each other. For example, I cross j is equal to, see, it's first let us consider the magnitude. A cross B is equal to AB sin theta. Its magnitude. So its magnitude is 1. Its magnitude is 1 sine angle between these two. This is I, this is j. The angle between these two is 90 degrees. So it's equal to 1. Now direction. The direction will be perpendicular to IJ plane. I and J are lying in XY plane. So to this XY plane, I cross J will be perpendicular in this direction. So in this direction K is there. Therefore I cross J is equal to K. Similarly, J cross K. This is J, this is K. To this plane, this is at 90 degrees. Therefore, you get I. If you take K and J, K and J are lying in the ZX plane. To this ZX plane, y-axis is at 90 degrees. Therefore, J vector comes. So you can easily remember writing in this manner. IJK in a cyclic manner. I cross J is equal to K. J cross K is equal to I. K cross I is equal to J, like this. Now, since vector product is non-commutative, I cross j is equal to minus of j cross I. Or you can write in another way. Let us write in another way. J cross I is equal to minus of I cross j. I cross j and j cross I, they are not equal, they are in oppositely directed, therefore minus sign came. But I cross j is equal to k minus k. Similarly, minus j k I minus I. Similarly, ki, sorry, this is I, ki is equal to j, so minus j. So in this way, see, for this, from this figure we can obtain this. If we go in the arrow mark direction, we get all positive things. If you go against the arrow mark, you get negative things. See, I cross j is equal to k, but j cross I, you are going against the arrow mark. Therefore, j cross I is equal to minus k. I cross k is equal to minus j. K cross j is equal to minus I. Like that, if you go in the opposite direction, you get minus values. If a is equal to axi, if a is equal to axi plus ayj plus azk and b is equal to bxi plus byj plus bzk, let us find cross product of these two vectors. So a is written here, cross b vector is written here. Now, using distributive property, with first term you multiply this plus this plus this, the three terms you get. Second time, with second term you multiply this and this and this, you get three terms. With this you multiply this, this and this, you get another three terms. So in all you get 9 terms. So out of the 9 terms, some are having parallel vectors. See, I cross I, the angle between them is 0, sine 0 is 0, so this becomes 0, this becomes 0, this becomes 0. So we are left with 6. And here also let us make use of this diagram. See here, axby, I cross j is equal to k. Here I cross k, you are going in opposite direction, so here you get minus j. So here minus j. Here j cross I, opposite direction, minus k. So here aybz, j cross k is equal to I. Here az bx, k cross I is equal to j. Here az by, k cross j k cross j means going in opposite direction, you get minus I. Now rewriting the terms, first I terms minus azby, I and I. Next j terms next k terms so in this way. So this is the formula to find vector product while solving problems. Actually this will be equal to determinant of a matrix in the first row I, j, k come. In the second row, components of a vector come. In the third row, components of b vectors come. By taking its determinant, calculating its determinant, we get this thing. So while solving problems, we follow this only. Now let us do the problem. First let us find scalar product is equal to 3i minus 4j plus 5k. This is axi plus ayj plus azk. First, scalar product a dot b is equal to ax bx plus ay by plus az bz. Ax is 3, bx is minus 2, ay is minus 4, by is 1, az is 5, bz is minus 3, so minus 6, minus 4, minus 15, minus 25. Now a cross b, that is equal to I, j, k, ax, ay, bx, by, bz is equal to I, j, k. Ax is 3, minus 4, 5. Next components of b, bx minus 2, by 1, bz minus 3. So here is equal to I. You exclude this column and this row, this minus this. Next, you exclude this row, this column, so you get 3, 5, 3, 5, minus 2, minus 3, plus k. Excluding this, you get 3, minus 4, minus 2, 1. So here you get I, 12, minus 5, minus j, here minus 9 minus of minus plus 10 plus k this minus this 3 minus 8 you get 7i 1 minus j minus 5k. Now let us consider some examples of vector product. V is equal to omega cross r. V is linear velocity, omega is angular velocity. Similarly, torque is equal to r cross f. L is equal to r cross p. P is linear momentum and L is angular momentum. So these are some of the examples. Tau is torque and this also called as moment of force. See, while calculating center of gravity we used this formula, torque is equal to force into perpendicular distance. Here linear momentum, this is angular momentum.